Welcome back. Today we're going to be talking about exponents. So exponents is a shorthand notation to tell you how many times something is multiplied times itself. Okay? So it's a short way of telling you how many times something is multiplied times itself. So there's a couple of terms that we need to make sure we know before we get started. Right? I have 2 and I've got a little 3 to the top right. Okay? So this is going to be said 2 to the third power. Okay? 2 in this case, or whatever the number is on bottom, is always going to be called your base. Right? So if I say, what's the base? The answer is 2. 3 is the exponent, right? It's going to be called the exponent of the power. Now I do want to make sure that when I say exponent, I say it can be, what is the exponent? This is called the exponent. Some people call it the power. I think it's a little bit abusive language, but whatever. If I say, hey, what's the power? It's the third power, right? But this position is called the exponent. A couple other terminology. Squared. Squared is when you raise something to the second power, okay? Because if you're finding the area of something, you're literally going to make it into a square. It's 2-dimensional. But when you're looking at a 3-dimensional figure, something raised to the third power, you're going to call it cubed. So something that is cubed is raised to the third power. So we start looking at how we're going to write these out. We've got 4 different forms that we're talking about. We're talking about exponential form, we're talking about factored form, we're talking about simplified form, and we're talking about how do you actually read it. Right? So this isn't really a math term, but I want to make sure that you understand how it's going to work. So if I see 3 to the third power, okay, that's telling me that the base, 3, is going to be multiplied times itself, the exponent or the power number of times. So 3 to the third is going to be 3 times 3 times 3. That's the factored form. The factored form is expanded. Okay? When you are asked for the simplified form means you actually need to do the math. 3 times 3 is 9, times 3 is 27. So if I say, what is 3 to the third? Most of the time, I'm going to be asking you to get to 27. When you use it in math, you're going to be asked to get 27. But for sometimes, when you're on your homework, you're going to actually be asked to give me 3 times 3 times 3. That's going to be something that, it's going to show me that you know what you're doing. The last thing is, how is it read? Like I said, it's 3 to the third power, but we have this new word, cubed. So we're going to write it is 3 cubed. 3 cubed. Okay? So now we look at our second example. Well, all of a sudden I don't have the exponential form. The only one I have is the factored form. So what do I have? I have 2 times 2 times 2 times 2. So what's the thing being multiplied by itself? 2. My exponent is how many times it's multiplied. So it's multiplied 1, 2, 3, 4 times. So it's going to be 2 to the fourth power. Well, if I multiply it out, what is 2 to the fourth power? 2 times 2 is 4, times 2 is 8, times 2 is 16. And how would it be read? It would be read 2 to the fourth power. 2, I gotta learn how to spell. 2 to the fourth power. 2 to the fourth power is how you would actually say it out loud. Now, sounds a little simple to hear me saying it, but I want to make sure that you write it down so that when I'm not here to help you, that you can still have something written to remember how to say it. Simplified form. Now this one's a little tricky, right? I've got 9. There's different ways you can get to 9, to be honest. There's one that's the most common, which is kind of what I was going for, right? So even though there's multiple ways, I'm only going to do it one way. The most common way to get to 9 is to go 3 times 3. Alright? And how would you write 3 times 3 in exponential form? Well, 3 is the base, because it's what's being multiplied. And how many times is it being multiplied? It's being multiplied 2 times. So 3 to the second power. It's also read as 3 squared. 3 squared. Okay? The last one we're going to talk about is 4 cubed. 4 cubed. Well, cubed means raised to the third power. So I know that I'm going to have 4 raised to the third power. It's going to be my exponential form. What does that look like what does it look like in factor form? It looks like 4 times 4 times 4. What is 4 times 4 times 4? What is 4 cubed? Well, 4 times 4 is 16, and 16 times 4 is 64. Now, maybe I cheated. Maybe I've done these notes before, so I knew that was off the top of my head. But if you didn't know it, feel free to go 4 times 4 is 16, and then right off to the side, go 16 times 4 and multiply it out. Okay? If we're multiplying by 10, all you do is you add a 0. And then adding a power does the same. So there's many zeros as there are powers. So, for example, 10 squared is 10 times 10, right? But if I have 10 squared, then I know that I'm going to have as many zeros as I do power. So I'm going to put 1, and then when I say squared, I have 2 powers, so 100, which actually is the same thing as what I would get if I did 10 times 10. And that's always going to be true. For 10 to the third, I can go 10 times 10 times 10. Well, 10 times 10 is 100, and 100 times 10 is 1,000, which is going to be my correct answer. I can do 10 to the fourth. 10 to the fourth is going to be 10 times 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Right? And that's easy enough. You can expand it. But what happens if I go 10 to the 12th? I don't want you to do 10 times 10 times 10 times 10 times 10 times 10 times 10 and write it all out. And to expand it term by term, it's really not my goal. So what I want you to do, think about this. There are as many zeros as there are powers. So if I go 10, I have 1 0. I know I need to get to 12 total. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When you're dealing with numbers this big, it's usually nice to put commas in. So I start at the right-hand side, I go every 3. 1, 2, 3, 4. So this would be 10 to the 12th. Why do I spend time talking about specifically what to do with 10? It's something that shows up a lot. Typically it shows up more in science. There's something called scientific notation. You're going to be using it a lot there. And trust me, there will be a day where your science teacher will thanking me for taking a minute to explain to you how 10 to a large power works. So what about other aspects? What if you have a negative? Okay? So I've got negative 2 squared. Remember to think about where the sign is. Is the sign being raised to the power? So negative 2 squared is going to be negative 2 times negative 2. Alright? Negative times a negative is a positive. So negative 2 times negative 2 is positive 4. Negative 2 to the third is negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. Negative 4 times negative 4 times negative 4. Negative 4 to the third power. I know that I'm going to go negative, negative, negative. 3 negatives. Well, the first 2 are going to undo each other because negatives are opposites. And so my last negative is going to hold. There's nothing to cancel it out. So I'm going to go negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is positive 16. And positive 16 times negative 4 is going to be negative 64. Right? So whenever you're looking at exponents, if you're having trouble thinking about what's happening there, especially if there's negatives, write it out. Even if you don't write it out in the middle of the problem that you're on, find a scrap piece of paper and write it out. It's going to help you. It's going to help you be consistent. Consider these 2 different scenarios. Parentheses, negative 2 to the 4th power and negative 2 to the 4th power. Now, if you were in class right now, I would ask them a question to anybody. What's the difference? Is there a difference in the 2? And about half the class usually raises their hand and says, yes, there's a difference. And about half the class usually raises their hand and says, no, there's not a difference. And then I ask the question, I go, well, do these 2 give me the same answer? And almost everybody says, yes, they give me the same answer. The correct answer is actually no. they don't give me the same answer. Because this one says negative 2 times negative 2 times negative 2 times negative 2. Alright? Well, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Right? Negative, 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 negative. 4 negatives, the first two cancel each other out. The last two cancel each other out. The second problem says negative 2 to the 4th power. Sounds like the same thing. I would even probably say it the same way in class. But you need to make sure that you notice the difference. In the first problem, the negative was being raised to the exponent. And the second problem, the negative is not being raised to the exponent. The exponent only raises the power of the thing right in front of it. So technically this second one says negative, parentheses 2, times 2, times 2, times 2. Right? So the negative is never being raised to the power. I go 2 times 2 is 4, times 2 is 8, times 2 is 16. The negative 6 out front, and it is negative 16 is my answer. Alright? The difference is the first one says the negative is raised to the second power. The second one says the negative isn't raised to the second power. What about talking about very, very, very large numbers? So if we see negative 1 raised to the 204 and negative 1 raised to the 1,257. Now, do I want you to write out negative 1 204 times and count it? No, I really don't. I really, really, really don't. It's a bad idea. Right? It's going to take you forever. But I do want to let you know, I know that we're still in pre-algebra right now, but this is a problem that you very typically see on the ACT or on the SAT, or even on the GRE if you want to talk way down the road. And so it's a logic-based problem. Okay? So to think about this, let's forget about this problem. I know that if I have negative 1 times negative 1, that's a positive. Right? As soon as I put another negative 1, it's now negative. I put another one, it's positive. And so it flips back and forth all the time. Well, I wonder what happens if we actually expand it out. So if I see negative 1 to the first power, that's negative 1. Negative 1 to the second power is positive 1. Negative 1 to the third power is negative 1. It's going to rotate off every time. Negative 1 to the positive 4, negative 1 to the 4 equals positive 1. And if we were in class right now, I would keep going until somebody raised their hand and goes, Mr. Copeland, you don't have to do it all the way to 204. I'd say, well, what do you mean? And you'd say, well, look, there's a trend. Everyone that has an odd exponent is negative. Everyone that has an even exponent is going to be positive. So if I have negative 1 to the 204, that means I'm going to have 204 negatives. That means I'm going to have 102 pairs that all cancel each other out. So negative 1 to the 204 is going to be positive 1, and negative 1 to the 1,257 has a negative number, an odd number of negatives, and that's going to be negative 1. To fill in our blanks, if the exponent is even, the resulting sign will be positive. If the exponent is odd, the resulting sign will be negative. Let's do a little bit of practice. I've got negative 11 to the third power. So I go negative 11 times negative 11 times negative 11. Now you have to ask yourself the question, is the negative being raised to the power? Yes, it is. So 11 times 11 is 121. And then what is 11 times 121? Now I'm going to cheat a little bit and use my calculator. Don't remember what it is off the top of my head. You would multiply it off to the side. But for the sake of time, I'm going to hurry us along. We find out that the answer is 1,331. I know my answer has to be negative because I only have one negative left over, right? These two cancel each other out. This guy's left. 3 to the third times 5 squared. Well, Mr. Cope, we talk about multiplying with exponents. Use what you know to find what you don't know. 3 to the third power is going to be 3 times 3 is 9, times 3 is 27. 5 squared is 25. So now, I've taken a problem I don't know how to solve, and I've turned it into a problem I do know how to solve. Again, we use my calculator. 27 times 25 is 675. And you shouldn't be using your calculator, but for the sake of time, making this video a little shorter, I'm going to. I've got 2 squared times negative 4 to the third. Well, 2 squared is 4. What happens with negative 4 to the third? Well, 4 to the third is 64. I know that my first power is odd, my second power is even, my third power is odd, my first figure cancels each other out. So this is actually going to be times negative 64. And I know that 64 times 2 is 128, that times 2 is 256, so I'm going to end up with negative 256. Okay? So this has been our lesson on exponents. I hope that you feel confident in it. If you have any questions, please feel free to ask. The biggest thing with exponents is just practicing. You're going to find that later this year we're going to spend, for the most part, an entire unit talking about exponents. And we're going to discover a lot of exponent rules to figure out how to deal with them. But we'll cross that bridge when we get there. Thanks for watching.